Hi, everybody. Pleasure to be here. And I'm here to talk to you about what if we could do machine learning models as tables. And we're going to start by discussing like why machine learning is training databases, introduce a concept called AI tables, and how we do this with databases like MySQL and Postgres, and walk you through them. So anyone that has dealt with machine learning before understands that data is the fundamental ingredient to machine learning. You need data to train any type of machine learning model, and therefore, it's essential to it. Now, a great deal of data already exists in databases, and that falls in the kind of like field of applied machine learning. So many use cases for machine learning with data that lives in databases already, and therefore it's natural to ask a question like, maybe machine learning and the workflows for machine learning live in the wrong place. Like right now, and kind of like the traditional classic applied machine learning makes it so that machine learning is another application layer or somewhere within the application layer. And with that, you have a lot of complexity. You have to kind of like do the model creation, the evaluation, the training, the deployment. Then after you deploy this, you have to integrate it into your applications. And then you have to do all the maintenance, the ML DevOps. And it just feels like it's too much complexity for one simple block that essentially is just part of one general application. And if you think about it, even versioning of machine learning models looks more like versioning data than versioning applications themselves. So, why not doing machine learning straight in the database? That's a question that we asked ourselves. And to give you some kind of like intuitions around this, imagine you have this table in a database where you have income and you know how much debt there is related to the income. And you can, create a query where it's like select from income table where income is 80,000 and you want to know what the debt is. And of course, if you have that data point, from this table, it will tell you that it's 25,100. But what if you select an income that is, not exactly 80,000, 85,000? How would you get that response, right? And that's the kind of like what happens with an actual table that you have today. If you don't have an existing record, then of course you're going to get a null. But you can think of machine learning models, as a representation of this data. And I mean, anyone that knows machine learning knows that that is a function that will fit the data. But then if you were to kind of, if you were able to query the models, then you could do something like, okay, select from the model where the income is 8,500 and 85,000. And then since you already have a model that fits the data that you have, you could get an answer for this. So querying a model will be similar to how you query a table. It's just that you don't necessarily have to have the specific data point. You can have an approximation to it. So, machine learning or treating machine learning models as tables could be, an unlocker for the way that we treat machine learning and apply scenarios. So select the variable you want to predict from the model and then the conditions that you want to pass. And if you do that, then let's call this magic tables AI tables. And the main difference from an AI table to a normal table is that a normal table you have data, and in an AI table you have predictions, or it generates a table, it generates the output based on what you have in your work conditions. And this helps us move the machine learning kind of like mechanics closer to the data layer rather than into the application layer. Now, in order to really do this in a seamless way, we still need to create those models and publish them as tables. And although for a lot of people, they love to do machine learning and they love to implement things in PyTorch, TensorFlow. For many others, and especially when you want to just build an application, you just want to build a model in the quickest way possible, and then find ways for you to trust this. So we need to cater for both audiences. We need to cater for people that know how to create these models and for people that know data but don't necessarily know how to create these models. Now, a simple way to get the heuristics of if we were to automate this, it will be an instruction such like this. You would like to learn specific columns from a table. How you got to the table could be the join of many transformations, but you would like to learn how to predict certain columns, and from a specific table or query, and then you would like to publish that model as another kind of like AI table. Now, imagine that we could, for instance, insert into a magic table called predictors, which will set up the same instruction. And we could do the same thing. We could say, okay, I would like to create this magic table. I would like to predict specific columns, and I would like to learn from this query. Now, if we do it like that, we're accomplishing that objective of not only being able to treat machine learning models, but also to create them in the plain SQL language that you have. And this is interesting because then you're moving machine learning down into your data layer, and you treat your machine learning problems in the same way that you treat any data problem in itself, and then you can kind of abstract all the complexity around machine learning behind this kind of abstraction of machine learning models as tables. And then in order for you to like aid for people that don't necessarily how to create machine learning models themselves, you can apply AutoML techniques to it. And since the data is already organized, then these techniques are actually much simpler. To give you a summary of this, traditional applied machine learning workflows are complex, and those workflows, from like the moment you have an idea all the way until you've made all the steps to get a model into your application, it can be a process of weeks to months. But if you abstract machine learning into the data layer, then you're using the same tools, you're using the same kind of query languages. You can apply automated machine learning, and it can be explainable because you can explore and relate to like the memory points or the vicinities, and you can customize it as well as you want. And this can take, instead of weeks to months, you can get up to speed in like minutes or hours. Now, this is possible, and we actually found a way to do this by exploiting the capabilities of certain databases to have federated storage. So a lot of these databases allow you to bring tables that don't necessarily exist in the database. So when you query those tables, they go into wherever you tell them they exist. And we made our kind of like server to behave the same way that a MySQL server will behave. So when you connect to it, it looks exactly like a MySQL database, but instead of tables, it has models. And by doing this, you can actually bring to your database, be it MySQL, Postgres, MariaDB, ClickHouse, you can bring external tables, in this case models, and then start querying them as they are. And then you can also use the same data that exists in your database to train those models. You can see and you can actually test and work with this implementation with visitors in GitHub, MySDB, but the best thing is to show you an actual demo of how this goes. So Zoran will walk us through it.
Okay. Hello everyone, my name is Zoran Pandovski, and I'm working as a full stack developer in MindsDB. In these 50 minutes, I will try to show you a quick demo about the features that Jorge already talked about, as how you can train and query machine learning models directly from your databases by using MindsDB AI table features. So let's just start. The prerequisite for this is for you to have MindsDB installed on your local machine. How you can do that is quite simple by using the pip. So you will need to do just pip install MindsDB in your virtual environment, and you'll get a latest version of MindsDB. How you can start MindsDB is by specifying a Python module name, the APIs that you will try to use. In this case, we will use the HTTP and MySQL APIs, and path to the configuration file. The configuration file is the file used for starting the MindsDB and loading some of the config variables that you've provided for starting the MindsDB. Let me just quickly show you what the configuration file contains. So if you can see here, the configuration file contains the path, the API. So right now we'll start the HTTP interface of MindsDB, which will be started on the host and the port, localhost and the port. The MySQL, this is MySQL MindsDB's API, so we will start that too. And there are like additional information here, like a storage dir, the directory where MindsDB will keep the configuration files, versions, and models files. And there is additional important key here, which is integrations, which is right now it's empty because we will fill out this through our graphical user interface. But in this key, you will need to specify which type of database you will want to use and to which database MindsDB should connect to. So let's just quickly start MinesDB. So running MinesDB will automatically start our graphical user interface that we'll call Scout. The Scout will automatically run on your default browser when you run MinesDB. Okay, so what I want to show you right now, it's let's imagine that we have airline passenger satisfaction data inside your database. What that database contains is a table that contains the information about the survey for the airline passenger satisfaction. Let me just quickly show you how that data looks in the database. So in this table, we have different features as travel class, customer type, purpose of the flight of the passenger, satisfaction level of the in-flight Wi-Fi service, of the checking service, baggage handling, and etc. And what we will try to do is to create the machine learning model that will predict the satisfaction of the passenger. So are they satisfied, unsatisfied, or certainly satisfied or dissatisfied? Okay, so let's go back to our graphical user interface. So since we have this data inside the PostgreSQL database, the first thing we need to show the Scout and where the data is and connect to the PostgreSQL database. How we can do that? It's quite easy. So you will need just to provide the name of the database, the host. This could be localhost, or if you're using a cloud, you can connect to your cloud instance and just provide the IP address of your cloud instance here, the port and the username for logging and the password. Clicking on connect, and right now MinesDB is connected to our data source. In this case, it's PostgreSQL, but it works with a different database too, like a MySQL, MongoDB, MariaDB, ClickHouse. Okay, the second thing that we need to do right now is to create a data source and show MinesDB to which table exactly it should connect. I will name this data source as airline data, and we'll create a simple query to get that data. So I will select all from public that airline passenger satisfaction, and just for the demo purpose, I will limit the query to 5,000 rows. Just to check if the connection is okay, you can click here to see if it's already connected to your databases. Just click on create. And right now, MinesDB is connecting to the databases, to a specific table, and it's creating a data source from which we will train the model. If we go to the data source section here, you can preview the data, and we can see all of the features that this data contains. We can sort them, search through them, query them, and etc. Before we train the machine learning model, it will be good if we are able to get some statistics for this data, like analysis, and see if there are some potential outliers or biases in our data. We can do that by using the quality option of Scout. So if I click on the quality option, right now, MinesDB will look in every column, analyze the data, figure out the quality of each column, and show us suggestions and warnings about the data. You can see here we have information for all features in our data. And for example, let's just see that MinesDB thinks that for the customer type, there is a one warning. So if we go there and expand that, you can see that MinesDB thinks that there are potential bias with this column. And it thinks that some categories occur too often or too little in this column. So it MinesDB thinks that loyal customer occurs too often as opposite of this loyal customer. But at the end, this is just left to the user to decide if he wants to use this column when training the model, or he can just simply ignore that. And there are also additional warning for additional features that MindsDB thinks there could be potential bias or outliers in the data. Okay, so right now we will try to create the machine learning model that will predict the satisfaction of the passenger. And how we can do that is if we go to the predictor section, we'll try to train the new model. The source will be airline data. Let's just call this airline survey model. The feature that we want to predict is satisfaction, so we will need to select that. And there is additional advanced mode where by looking at the data analysis, we notice that for customer type, for example, could be potential bias in the data or for other features. So here you will have an option to exclude those from training the model. But right now I will just leave it as is and just click on the training model. Right now the training will start and it will take some time to train the model. Depending on the data, what kind of data you're using, how many features you have in the data, types of the features, and etc. So we should wait like some n number of times to see this data. Okay, so right now we can see that the training of the model successfully finished. So we have complete as a status of the model training. And we can see that the accuracy for this model is quite big. It's around 95%. Let's just preview the model. Okay, so right now we can see the test accuracy of the model here. We can see the data set splitting. So how MindsDB split this data set. So we select like 5,000 rows. So MindsDB divided that by training data and the test data for checking the accuracy of the model. There are additional information here that we can get from this trained model. It's what MindsDB think is very relevant for the model that we have trained. The column importance starts from 0 to 1, and the higher value means that MindsDB thinks this feature in the data is quite important for the model and for getting a good prediction. So we can see right now that MindsDB thinks the in-flight Wi-Fi service is quite important for the passengers, the type of the travel, the age of the passenger, online boarding, flight distance, and etc. Additional thing that we can see here is when you can try when we can ask this model inside the confusion matrix, we can see that the model 96% of the times predicted neutral or dissatisfied and was correct, and also how many times predicted only satisfied as was correct, and again the when model made a wrong decision. Okay, so right now we have the trained model. So how we can get prediction back from it? So we are coming to the next section that is called querying the model. How you can query the model is quite easy. So you will need just to select the model and add the information for which you want to get information. So for example, let's just think that this passenger was quite satisfied of the in-flight Wi-Fi service. So he rated it as a 5-star. He was traveling for the business travel. Just add that age there. Let's just add additional information as a type of the customer. So let's say that the customer is loyal customer. And let's just try and query the model and see what MindsDB thinks about this passenger. So it should take like seconds to give the predictions back. And right now, what we can see here is we can see that the model predicted that the customer for which we entered the values was quite satisfied. So in the explanation section, you will notice that using the values listed below, the trained model predicted satisfaction with 99% confidence. And you can see the values that we entered for querying the model. There are additional extra insights that the MindsDB tried to give you additional information, and we're trying to guess how the model would predict it if some of the values that we added here were missed. So if customer type was missing, the model again would have predicted satisfied, and quite similar for the other feature. But if we have more features there, I guess for some of those, the model would have predicted other values. Okay, so yeah, that was in a short how you can use the graphical user interface to connect to your database, train the machine learning model, and using the queries, get the predictions back from it. What I will want to show you right now is how you can do the similar thing through your database console. In this presentation, I will use the PostgreSQL client, but the same could be done through other databases too. So how we can create the machine learning model is quite easy, and we will need to execute just the insert query. What that insert query should contain is, so we will try to insert inside the mindsdb.predictors table. And what we will provide is the name of the model. In this case, it will be airline model. The feature that we want to predict, it will be the satisfaction. And the select data query will be the query that will ingest the data from the database. So let's just try that. We need just to add the schema here. So I need just to add this as a string. Sorry about this one. So in the background, the insert to predictors query will call mindsdb, that will do the black box analysis and start the process of extracting, analyzing, and transforming data. And it will take some time again to train this machine learning model. And how we can check the status if this model has successfully been trained, we can just do the simple select query from the mindsdb predictors table. So if we select from mindsdb.predictors, you can see that the airline model right now status is training, so we should wait for it to train. And you can also see the model that we've trained here through our graphical user interface, which is completed. And also you will be able to query this model through the SQL interface here, even if it's trained from the graphical user interface. But also, even if this is trained through the graphical user interface, you will be able to query that to PostgreSQL and also other databases like MySQL and MariaDB or ClickHouse, etc. So let's just wait for some time for the model training to finish. So we should just, okay, so right now we can see that the status of the trained model is complete, and the model is trained again with around 95% accuracy. How we can get the predictions back from this model is quite similar to what we did through the graphical user interface using the query options. That can be done here using the select statements. So we will try to select. We'll try to select the satisfaction confidence from the new trained model called airline model. This model right now behaves as a SQL table. That's why we will be able to run select query against that. So if we run the query, it will take a few seconds before MindsDB provides answers back. And right now you can see that MindsDB thinks that the predicted value is satisfied and the confidence for it is around 97%. There is additional column that we can select using these select statements that is called explain function. and it will provide us additional information about this prediction. So let's just try that one. What's the difference with this query and the previous one is that right now I'm also selecting the satisfaction explain column, and let's see what that will return. Okay, so right now, except the predicted value and the confidence, here we can see additional information. The important missing information shows the list of features that MindsDB thinks are quite important for better prediction. In this case are the age, the flight distance, gate location, online boarding, and onboarding service. We can also see the if missing option, where what would have MindsDB predicted if some of these features were missing from the where clause here. So if customer type was missing, MindsDB will still predict it satisfied, but if in-flight Wi-Fi service was missing from the query, MindsDB could have predicted neutral or dissatisfied message. So yes, I think that pretty much covers what we will try to present right now. So we covered the basics flows, like how you can connect to the database, how you can get the data analysis from MindsDB to get additional information about potential outliers in your data, how you can train the machine learning model and just query it through the graphical user interface, and how also you can use the pre-trained model from the graphical user interface and query it directly from your SQL client, and also how you can train another model with simple insert statement, and how you can query the model with simple select statement. Thank you.
Thank you very much. So you still have 15 minutes. So if you want, you can ask questions in the Slack channel, for example.
Okay, what type of machine learning models does Excel support? Is it open source? And what's a revenue model? So right now, we support models based on the data types that you have. Essentially, you can break any table into the different columns that you have, and the columns may have different data types. Right now, we support images, text, time series data, numerical and categorical, and the same thing for whatever columns you want to predict. And the way that we do it is by building embeddings from each of those columns. So the way that most of the research in machine learning kind of moves forward is in data type. And we take the state of the art for each of those columns. So we take the state of the art for, say, for instance, text and text embeddings, and we generate embeddings from this. And then from there, once we have embeddings from each of those columns, then we build an ensemble of models to get to your target variable. But most of those models that we have are purely neural network based. As to it being open source, surely it is open source. Our mission is to ensure that as many people can try it and use it. And our business model is on features that are only relevant to certain use cases within the enterprise. So being open core, we enable most of the functionality to everyone, and just things that about like how can you run this in a cluster, or how can you make sure that there's integration to other authentication protocols, and things that don't really have to do with the machine learning or machine learning models as tables. Those things we pack within our enterprise package. But the cool thing is that you can start with the open source, and once your needs get to a certain scale, then you can operate for enterprise.